You're asked to consider the values on the x-axis and corresponding subscript values shown on the right. So we're asked to write a linear equation for x of k. So remember here, I'm going to write this into something maybe you see as more familiar, because really I can kind of rewrite this as a table where k is all of these little values, right? So 0, 1, 2, 3, and 4. And then x of k is equal to all of these values here. So I got 3.5, 4, 4.5, 5, and 5.5. And when I'm trying to find a linear equation here, I first got to find the slope, or what is the constant rate of change. In this case, it's going up by 0.5. And then my intercept here, or where I'm starting, is 3.5. So my linear equation here will be x of k equals 0.5k plus 3.5. So that's my linear function. Now we're being asked to express 3.5 plus 4 plus 4.5 plus 5 plus 5.5 in sigma notation. So when we are doing this, a couple of things here that we're going to start with is that I already have an equation, right? Because I have an equation that I already created for this piece here, which is going to be 0.5k plus 3.5, because that's the equation that represents each of these values. Every time I go up by 1, then I get these values inside. So what I'm going to be doing here now is, where do I start? Well, again, look back at this table we created. Where's the first value that we plug in? 0. So I'm going to start at k equals 0 here, and then my final value that I plug in is k equals 4, or just on the top we write 4. If we were worried about, hey, is this correct? We'll just try it, right? Plug the 0 in. 0 times 0.5 is 0, plus 3.5 is 3.5. So I got my first value. I plug in 1, because that's the next value it goes. 0.5 times 1 is 0.5, plus 3.5 is 4, and so on. You would see that they all match up. So for C, for some function f, express f of 3.5 plus f of 4 plus f of 4.5 plus f of, all of that in sigma notation. Now, this one is a weird question to ask. And honestly, I expect a lot of people, as they do this problem, to say, like, what the heck, man? Like, why am I doing this? But it does kind of come back, because basically what we are doing here is, instead of actually just having one equation in sigma notation, I'm really having an equation that I am plugging in to a different function here. So I know it seems stupid to just say, like, oh, it's f of all of that. Like, Mr. Riddle, that teaches me nothing. But eventually, f is going to be equal to some other equation, like, let's say, x squared. So like, when we do that and we plug it in, right, we're going to say that when we plug that in, 0.5k plus 3.5 squared, because we're using kind of composition in this idea here. So we're plugging that into another function. So yes, in this question, just writing the f is like, Mr. Earl, that doesn't do much. But in the future, we're really going to be plugging this linear equation that we create over here, this linear equation we create from the beginning, we're going to be plugging it into a different function for sigma notation. The last question says, how are they related? Really, they're just building on each other, right? We first use what we know about tables to create a linear equation. Then we use that linear equation within a sigma notation. Then from there, I'm going to use what we know about sigma notation and plug that linear equation into a new function. Again, all of this builds on this bigger problem, this bigger idea. And if we can understand the small pieces, then the big piece becomes a little bit easier.